This week, my main focus is keeping all the machinery in the shop running so that we can finish all of our restocking and get everything shipped out that was ordered during Black Friday. Yesterday, we got a big box of material delivered, so I'm going to show you guys how I divide that up between all the machinery and figure out what material is going into each machine. I'm also going to quickly go over the setup process as far as what it takes to go from one job to another job in a CNC machine. But before I head out to the shop, I want to show you something else that I've been working on just for my own personal 8.6. During Black Friday, Panic had a sale on their Link ECUs for the A86, so I took advantage of that and bought one for my Corolla. I've been using the stock ECU on that car since I did the engine swap about a year ago, and while I would say it probably runs about 90% good, there are still some small things that I have not been able to get to work perfectly. So I think the best bet for me is just to go ahead and put the full standalone on, and the reason that I like the standalone systems is that once I've got a standalone on the car, then I can plug into it and I can see everything that's going on. The biggest problem that I've had so far with the original factory ECU was getting the OBD2 scan port to work correctly with the scanners that I have. So the Link ECU is going to eliminate that problem completely. But part of putting a standalone on the car is I can also get rid of the airflow meter and the factory intake manifold and electric throttle body. Those are the things that I really am excited to get rid of. Now, if any of you guys are familiar with the products that we offer for beams, I already offer an ITB adapter to use the blacktop 20 valve throttle bodies. That's an option for me to use on my car, but I kind of wanted something unique and different. But before I show you what I'm working on, let me show you what we have currently available for beams. This is an adapter plate that puts the AE111 blacktop individual throttles onto the beams engine. So there's a couple of things that make this really great, and a couple of things that I would improve if I was designing my own complete ITB setup for this. So number one, the things that work really good on this is that it's very simple. You literally just take off the original intake manifold, you bolt this adapter on, then you put the 20 valve throttle bodies on, you hook up a throttle linkage, and everything works. It's super, super simple. The things that I would improve on if I was designing my own complete individual throttle body set was there's a large stack up here. This is the first thing that I don't really like, is that the cylinder head is here. There's an adapter plate here. There's another adapter plate here. Then there's an adapter plate here. And then you have your throttle bodies. So there's just a lot going on. Lots of chances for things to leak. It's not that big of an issue, but if I were to design it from scratch, I would want something that's really just designed specifically for this and not just adapting a bunch of stuff together. Can we also take a second to acknowledge that that's a super awesome Super Mario Bros. 3 poster? The next thing that I don't totally love about using the blacktop throttle bodies is that the throttle body spacing is quite a bit narrower than the Beams 3SGE spacing, meaning the cylinder positions are not lined up perfectly. The cylinder spacing is wider or more spread out on the Beams engine, obviously because it's a bigger engine, larger displacement. The pistons are further apart than on the 4AG engine. This means that the two center ports of the 4AG are pretty straight in there. It lines up pretty good. But the two outside ports have to turn as they go in. So this port is going this way before it goes in, and this port is going that way before it goes in. So this isn't a huge problem, but it's not perfect. So anyone that's been following our page for any length of time has seen the individual throttle body setup that I pretty much put on all of my mock-up 4AG engines. It's a Gen V 45mm throttle body setup. Now the reason that this is going to be better to put onto this Beams engine is because its throttle spacing is much closer to the 2-liter Beams engine. Let me show you a picture of the throttle bodies that I'm talking about. So the next thing is to figure out how can I use those throttle bodies on the Beams engine. I obviously have to make an adapter, but I don't want to just use an adapter on an adapter on an adapter. I want to bolt it as close to the head as I can. Now bolting directly to the head is pretty difficult, mainly because the plane for the flange is vertical like this, but the port is at an angle like this. So what this first adapter does is it takes that angled plane and aligns the port to a point where you get a plane that's perpendicular with the port. So I think I'm going to start with my intake adapter after this first adapter, eliminating these two things. Let me take all this apart and you can see where I'm going to start from. So here's what we got with all that stuff off. I actually really like what this little manifold or adapter is doing here. It's taking the ovaled port and it's turning it into a round port. and it's spacing them out very evenly across. So this is going to be very easy to create an adapter that goes directly onto this to our Gen V throttle bodies. But first, I need to figure out where all of these holes are because I've never designed anything that bolts to this. So there's a couple of ways to figure out the positioning of all these holes and the spacing of these ports. You could 3D scan this. I could put this on a CMM or in one of my CNC machines and try to pick up the location of all these holes. But all of my machines are busy right now, so I can't do that. I'm gonna go back to the super old school method of just imprinting this design onto a piece of construction paper and then measuring the imprinted lines that I've created on the construction paper. Then I'm gonna draw that up in CAD. I'm gonna 3D print just the hole positions first to make sure that everything lines up, and then I can go in and design my adapter. So honestly, this is something that anybody can do at home if they wanted to start designing their own products, and you can 3D print using free software. It's very inexpensive to come up with your own products. So I usually just take a piece of paper like this and I rub my fingers around the areas that I need to measure. And this is just gonna look like a bunch of dirty lines on this side, but because all of the edges are actually sharp on this original part, it's gonna leave nice clean lines on the other side that I can use for taking measurements. So here's kind of what you get on the other side. You can see that all of these lines are actually pretty easy to see. It's really clear. And then what I do is I create a reference line, which is this line all the way across. I line that up with the bottom of each port because I know that those are all in line with each other. And then from that bottom line, I create a center point, which is based off of this first bolt hole. Now that's just coincidental that that bolt hole happened to be in the center, but a lot of times manufacturers will do stuff like that, so you can use that as a reference. So I use a 90-degree angle to create this center point right here. So now I have a line that I can measure from that's on the base of all of those ports, and a center line that I can measure from that's based off of that one bolt hole. The reason that I like to go from the center line is that my margin of error is reduced by 50% when I go from the center line. For example, if I start over here and I need to measure the distance over here, I'm going to end up stacking up the measurements between all of these holes. And that's going to most likely be further away from perfect on my first print than if I measure from here to here to here and from here to here to here. So these are the actual measurements that I took off of this, and if you want to design your own Beams ITB adapter, feel free. The port size is 1.825 inches, which is a little bit bigger than 46 millimeters. That's why I did it in inches. I took all of my other measurements using inch measurements, but then realized that it's very easy to convert to what Toyota was trying to do. And for the bolt hole spacing on the outside of the right side of the adapter, it's a 90 millimeter spacing. From the center line to the first bolt hole is 95 millimeters, and it's mirrored on this bolt hole is also 95 millimeters. And then from this bolt hole to the last bolt hole, for some reason, was not an even metric number. So it came out to about 3.125 inches. Now, this is obviously not a super accurate way of measuring, but what I found is that this is actually going to get me much closer than you would expect, so that I can 3D print just maybe like a 0.5 millimeter thick flange, and then I can verify the fitment and make any adjustments that are needed after that. So I took this and I put it into CAD. Let me show you what that looks like. Okay, so here's the CAD drawing. What I did is I took these circles for the ports, I added the bolt holes, and then I took some basic measurements and offset some of those lines to create the outside shape. It's actually much easier than you think. For example, if you take that bolt hole, you just draw a 3/4 inch circle around the outside of it. And that bolt hole, you draw a 3/4 inch circle on the outside of it. Same thing with this one. And then I offset the ports, I think 1/4 inch. And so that gives me the geometry around the ports here, there, and there. And then I drew a center line across the part, and that's where I got my lines here. And then I was just able to connect all the geometry. Once you start drawing, you'll understand that that's actually a very fast process. So the next step was to take this that I've designed, create that into a 0.5 millimeter solid, and then go and 3D print it. And so here's that gasket or 3D printed first version. I actually got pretty lucky on this one. There were no changes needed to this first print. So this is a verification process that saves you a lot of time. If I were to have just gone ahead and drawn the whole thing, I could have potentially had to redraw it because just this geometry would have been off. So I do know that this geometry works good. Now I can go back and design the actual adapter. So the next step was bringing in all of this geometry on the top here, this stuff. This was just brought in from the ITB adapter that I designed for the 16 valve and 20 valve engines that use the same throttle bodies. So I just copied it from those ones, brought it in here. The next thing that I did was align the ports on them the best that I could. So I took the center lines up and down this way and aligned all the ports together, and then I centered the throttle bodies on the center of our adapter. So this actually is a good representation of our port alignment. So the alignment that I was talking about on the AE111 throttle bodies versus this is actually much better. If we zoom in over here on our extreme case, we're just barely off center on our number 4 and number 1 ports. Our 2 and 3 line up pretty good. There's not a lot of surfacing that's going to be required to machine this. Let me show you our blacktop throttle body adapter for reference. So here's the solid model for that AE111 adapter. So not only are the ports kind of a weird D shape, but let's go over to the number 1 port and you can see the misalignment is much greater than on the Gen V adapter we're working on. So back to the Gen V adapter, here I have the geometry. What I've done is I've adjusted my geometry position to get the adapter height that I want. So this spacing right here is the length of our beams AE111 adapter plus that original rubber insulator. So now it'll just be 1 piece instead of 2 pieces. The next step is just a simple extrusion of the base, a loft extrusion of the port shape, and then another added boss of the outside of the throttle body shape. Then I added a bunch of fillets to it. I'm not going to bore you with the design of it, but this is what it looks like. So this is a very simple adapter. Now I can 3D print this and just verify fitment of the throttles on the engine. All right, here's the 3D printed adapter now. You can see it goes in between the original adapter and the Gen V throttles. I think this looks a lot nicer and cleaner than the AE111 setup. And again, like I said, the spacing is much better. So this is as far as I've gotten with this own project for myself. I haven't received the Panic ECU yet, and I don't plan to install that probably until early next year. But this is at least a good head start for an ITB setup for my car. So now that I'm done playing around with my own personal project, let's go out to the shop. So yesterday we got about 500 pounds of aluminum delivered in this box on this pallet. All of this material is for our restock for our Black Friday orders. This is about half of what we have to get done before everything for Black Friday is shipped out. When I order this material, what I'm doing is I'm thinking about what machines are available, about how long is it going to take to run, and then I order enough material to keep all of the machines busy for about the same amount of time. That way I don't end up with one machine that's got nothing to do while the other machines are still running. After the material arrives, what I'm going to do is I'm going to take it all out of the box, I'm going to go through it, make sure everything is correct, and then I'm going to stack it on the tables in front of each machine that it's going to be run on. When we're not in a normal production cycle and we have a lot of stuff going on, Stacy and I will actually create a list of all of the things that have to be done within the next couple of weeks. So on the top of this list from last week is all the material that's in this box here. That was our main priority to get that ordered so we could have it here this week. The next thing on the list is going to be the material that needs to get ordered for next week's worth of machining. So I still need to order that by tomorrow. Once we've got everything figured out as far as what needs to be ordered, then I'm going to go in and I'm going to itemize based on machine. So here we have our VF2 machine. This is all the stuff that's going to be solely run on the VF2 machine. This is the DM2 machine, the VF1 machine, and our 2 Mianos. When I'm dividing this up again, I'm trying to figure out the best workflow to make sure that all the machines are always running. So now that all this is figured out, let's get all this stuff unboxed and laid out in front of the machines. All right, I got all the material laid out. Oddly enough, it was good that I inventoried it because we're actually short on quantity on our EF radiator brackets. We ordered 60 pieces, only 44 pieces showed up. So luckily now I can just send an email out and they'll send us the rest of them. But for our VF2, beam shifter relocation housings, reverse lockout bearing housings. This is the part that holds the bearing in the middle of the shifter. EF radiator brackets and reverse lockout shifter bodies. So the way that I chose these as far as going on the VF2 is that all 4 of these parts require the use of the 4th axis, and the VF2 is the only machine that has our rotary 4th axis in it that we can use for milling. So that's how I picked those parts for the VF2. Now over on the VF1, this is our machine that is sort of our oddball. This is the one that does all of the unusual products, such as shift knobs, or if we run an odd material like plastic or steel, it goes in this machine. So over on the VF2 table, what I've got is our Toyota oil caps, and then our OP1 and OP2 for our beams, engine mount base plates, and our reverse lockout OEM location shifter mounting bracket. These are all going to go in the VF1 this week. Now over on the DM2, what I've got is a remainder of window cranks, because we actually sold out of the 200 or so window cranks that we had made over the last 2 months. This is just so that we can finish fulfilling all of the Black Friday orders. I got to run through these really quick. And then we've got some distributor plugs, and this is a little cap that goes on top of the reverse lockout housing. So that's what I got going on in the machines. Oh, I almost forgot. Over in the Miano right now, I'm running our beams ITB adapter dowel pins. Now this is probably one of my most reliable processes on the Miano. It makes these tiny little dowel pins. And this runs so flawlessly, I'm comfortable. This thing just runs bars all day long until we stock up on these. Let me actually show you one of the cycles of this. Okay, so this lathe normally runs completely uninterrupted, and it runs continuously. I just stopped it so that I could film this video, but I'm gonna start it up again. So the machine starts with just a facing tool to trim off the face of the part, and then it slowly turns the precision outside diameter. And the outside diameter is actually done in one shot because that's when the material is its strongest. After the outside diameter is turned, then comes the spot drill and the drill to do the through hole in the center. After the center hole is drilled, then the parting and grooving tool is going to come out. It's going to chamfer the back edge before it parts off, and the machine's going to catch it. Throws the part into a basket, and then the bar puller comes out. Grabs the bar, pulls the material out to the correct length, and then it starts over again. And this will probably just be running all day. I'll probably make a couple of hundred of these dowel pins on 4 or 5 different bars. So I was in this video going to go over setting up a job in the CNC machine and how it goes as far as tearing down the previous job and putting the new job in, but this video is already getting kind of long, so I'm going to be doing this for the next couple of weeks. What I'll do is I'll put it in next week's shop video, sort of the tear down of a job, setup of a new job, about how long that takes, and about for how long each job is in each machine before we move on to the next one. So thanks for watching. I'll see you guys next week.